Hello everyone, so welcome to a new video. So in this video what we are going to create is a simple animation made in CustomPaint. So it is not anything advanced at all. I'm just going to create a very rudimentary sun and earth orbit kind of animation in Flutter. So first of all, we do have this code, and if you look at this main page, right, we don't have anything fancy. I'm going to increase my font so that it will be easier for you guys to see. And here you can see that I am just in the home. I am just returning a container, and if you look at the home page, right, there is nothing else. So throughout this tutorial I'll be running the app on the Windows, and you can run it on your phone or anything like that. It is not mandatory to run it on the Windows. And you can see that there is nothing in this app, so because we are just returning a container, and it is black because there is no scaffold either. And for this tutorial I'm going to use this theme data.dark, so it will be dark theme throughout this tutorial. Alright, so first thing we are going to create is a stateful widget. So I'm going to import the material package, and I'm going to use the Android Studio handy shortcut to create a stateful widget, and let's just call it orbit animation. It doesn't need to be fancier than that, and I'm going to, let's just say, yes, let me just put it here and put our app here. Alright, we won't be needing that, so let me just hot restart. Yeah, okay, I forgot, I have to call this in the home and import this page. Alright, okay, so now you can see we are calling the orbit animation, and since here we are returning a placeholder, we are seeing the same thing here. So I'm going to replace it with a scaffold, and here we have a simple page. Here the first thing we need to create is a class that extends the CustomPaint. So for that I'm going to create a class under here, and let's just call it Orbit Painter, which extends the Custom Painter. And you can see that Custom Painter is a class, and here we have to override this paint method and also this should repaint method compulsorily. That is why here Android Studio is showing us an error that I have to override these two missing functions. So I'm going to do that. So we'll be drawing everything using this paint method. Everything we need to be drawn to the screen has to be written inside this method. And for now I'm not going to bother about the should repaint or the paint method, because I need to first call this our own custom in the custom paint widget. And inside the custom paint, for the paint parameter, right, we have to call our class. So in this case I am going to call this orbit painter. So if I do anything, hot restart, you can see we are getting an error, right, because we have this unimplemented error. So for this case I'm going to return false, and again hot restarting. There is nothing on the screen and we don't have any errors either. And now comes to the point where we have to draw something on the screen. And for the first example I'm going to just write canvas, and if I type draw, you can see that we have a lot of functions available for us. So we have draw image, we have draw atlas, draw line, draw circle, and a lot more. And for this case, right, I'm going to show an example of how we can draw a line in our custom paint. So in this draw line, right, it is expecting two offset points P1 and P2 and a paint. So P1 and P2, if you imagine, P1 and P2 will be the X and Y coordinates in our custom paint. So how do you define a point in the custom paint? We do that using offset. So an offset takes in two parameters, the one that is for the x and the another one that is for the y. So here I'm going to say that x equal to 100 and y some number like 50, and I'm going to just copy this code and paste it here, and here for the x I'm going to change it to 200 and I'm going to keep the y as the same. Now writing these two things doesn't necessarily mean it is going to draw anything on the screen. So now that we have defined the two offsets, the third parameter we have to pass into this draw lane is the paint. And if you look at the documentation, you can see that in this class paint, a paint is a description of the style to use when drawing on a canvas, and that is pretty much the explanation needed. To draw something we have to define its color, its width, and the lane can have a stroke width. All those things can be defined using paint. So I'm going to write final paint equal to paint, and if you use the spread operator you can say that I want the paint to be of the colors dot yellow. And after you define your paint, right, in this case I'm just going to leave it with one color only, I'm going to pass it to the canvas draw lane function. So what we have here is a draw lane and with 2 points P1 and P2, and the P1 is at the offset 150, P2 is at the offset 250, and the third parameter is the paint, which is of the color yellow. And if I restart my app again, you can see that we have a teeny tiny small yellow lane here. It is drawn from the x point 100 here and towards the y point 200 here. So one of the pro tip I want to give to you when you're creating with custom paint is that if you want to have functionality for zooming into the canvas, then you can use the handy widget provided by the Flutter team called interactive viewer. And inside the interactive viewer, right, there are some parameters, and if you look at this, there is this maximum scale and minimum scale. So if you leave it like that to the default values, you can see that if you hot restart, we are not seeing anything, because in this case we have to pass a container. We have to write this custom paint as a child called container, and because container by default will grow to the entire size that its parent has, if we hot restart we can see we have this yellow lane here. Now you can use your mouse to zoom and pan around, right? And for this case, right, in the interactive viewer, I'm going to override the max scale to be 10, and let me hot restart again, and you can see that in this case I'm using the mouse and I can zoom in and pan around the custom paint. And throughout the tutorial series you will see that I'll be using interactive viewer a lot, because it helps with zooming and panning around our custom paint area. So this is how you draw a lane in canvas. Now the other method to draw is called canvas dot draw circle, and here the first parameter you have to pass is, if you look at the documentation, is C, that stands for the center, and the second parameter is the radius, and third parameter is the paint. So you have to define where you want the center of the circle to be in our canvas, then you will pass the radius of your circle, and then you have to pass what color you want your circle to be. And if you hover around here, you can see our handy dandy Flutter documentation shows us exactly this thing. So the x and y, if you want the circle to be centered at the center of the screen, right, then you have to pass the offset which will have the x and y at the center. So how do you do that? I'm going to just show you that here. So for the center, I'm going to pass in the offset, and I'm going to just say 100, 200, 55, whatever the case. And for the radius, which is a double, I'm going to pass in 100. And for the paint, I'm going to use the same paint I created for the line, so a yellow color. So if I hot reload again, you can see we have a circle here. And because I'm using interactive viewer, I am able to zoom in and zoom out as well. This is the minimum scale you are seeing now, and you can see this circle is drawn at an offset 100 on the X. The center here is X 100 distance away from the left side and 255 distance away from the top side. And if I want it to be further away, I can say 500. And if I hot reload again, you can see that now the circle is much further away from the left side, and the Y side is still the same, 255. If you want the circle to be exactly at the center of the screen, right, you can use the size provided by the paint method. So what you can do is, inside the option you can say size dot width divided by 2, which will be somewhere around the middle point between the width of the size. And you can exactly do the same thing for the Y coordinate, but in this case we can use the size dot height by 2. So if I hot refresh again, you can see that the circle is at the center of the screen. And if I change the parameters again, right, you can see that it will always be at the center of the screen. So this is how you draw a circle in the canvas. And now you can start to see where we are going with it, right? So I'm going to remove the draw line. I don't need that line, I do need the circle. And in our case we are going to use this as the sun, and I'm going to rename this variable to sun paint. So the next thing that I want to do is draw the orbits around the circle, right? And for that I can do this. I can just duplicate this line. Instead of radius as 100, I'm going to mention something around 200. And instead of using a sun paint, I'm going to create another paint called orbit paint. And I want the orbit to be of the color gray dot with opacity something like 0.5. so I have to use this orbit paint for the second row circle parameter. And if I hot reload again, you can see we have a yellow center circle and then gray circle, but because we have passed in opacity as 0.5, we can see through this opacity circle and we can see the yellow circle beneath it. If you want, you can also put it at the first line, and if you hot reset, you can see now the yellow is more brighter. In canvas, this is the order of how things will be drawn. If you want two things to be drawn at the same place, then whatever you write first will be the one that will be beneath everything else, and everything that you write beneath there in your line of code will be put on top of each other. Now that we have an orbit, right, the next thing we want to draw is Earth. So I'm going to create a paint object for Earth, and for Earth, right, I'm going to copy this code and make a small change. I want the Earth to be of the blue color, and let's just put a opacity of 0.9. Let's just create few parameters, final Earth radius, and let's just say 20. And we want to draw this circle again, and instead of sun paint, let's just pass the Earth paint, and instead of stating 100, let's just pass the Earth radius. Let's just put it as constant. Yeah, it needs to be a double. Alright, so now when I hot reload again, you can see we have a Earth, but it is positioned at the center of the canvas again, because we are passing the center. The same we pass for the orbit, and as the same we pass for the sun as well. So what we need to do is figure out what this parameter should be. So if I hard code this thing, right, maybe I can do this. Let's just see where this 200, 300 will be. Hot reload, yeah, it's away. So maybe I can decrease the Y distance, maybe increase the Y distance, because in the canvas the y is 0 at the very top, so I want it to be a little bit down, so let's just say 330. Nope. How about 380? Now it is inside. As you can see, it is not ideal to hardcode the distance like this without knowing, right? But we do have a point, right? We know that the orbit is at the distance 200 away from the center, and like then we can use the same calculation to calculate where the earth radius should be. So I'm going to just say Control Z, and inside here, right, inside the size dot height, if I add this same parameter, the earth orbit radius or something like that, you can see that if I hot reload, right now the earth appears to be the same position where we want it to be, and it is because I have added the 200 parameter, and this 200 parameter came because the orbital circle's radius is 200 parameter, and since I'm drawing it from the center of our canvas, right, I'm just saying that I want the height to be at 200 distance away from the center of the canvas, so it will always be here. So now you can see that our code is looking more like a solar system, but I don't want this orbit to be of the gray circle, right? So what I can do here is that inside the orbit there is another parameter called scale, and here I can say I want the scale to be painted scale dot stroke, and that only the outline will be drawn, everything inside is not filled. Okay, so now our animation is looking more like a sun and earth at an orbit, right? And if you want, you can also remove this as well, but to make the contrast more easy to view, I'm going to say the background color of the scaffold to be colors dot black. Perfect. Now you can see our canvas is black, we have a yellow sun at the center, and we have an earth here as well. You can also zoom into this canvas to see what I have created. You can always use an interactive viewer when you're working with canvas or with any other widget if you want to zoom in and look at all the things. Alright, now that we have created our canvas, we have made the drawing, right? The next step is the animation. How do we animate this earth to rotate or revolve around the sun? There are a couple of ways to do that, but the very first thing you need to create is an animation controller inside your stateful widget. I'm going to use this single ticket provider state mixing, and this way I can at the init state override and create the animation controller. So let animation controller, then I can say that animation controller equal to animation controller, and we sync this, and I want the duration to be, for this case, duration of seconds 5, and what I need to pass is this animation value to the custom paint. So inside my orbit painter, I want to receive the animation value here, so that I can use that animation value to recalculate where I want the earth to be. So I can say final, and I want to create a constructor. You can either use, and next thing I want to pass is this animation controller, and water value I am getting in the inside the animation controller too. Oh yeah, I don't need to pass in the value, I just need to pass the animation controller here. And if I hot restart, nothing changes at all. Although there is an animation, right, I'm not actually reusing that anywhere here. If I want to see if the animation is working or not, I can directly use this animation to control, for example, this radius of sun. So I can say that I want the radius of sun to be, so if I hot reload, right, you can see that the sun is not visible. If I hot restart again, you can see that sun is not visible. The reason why is because animation control default upper bound and lower bound is between 0 and 1. So when the animation starts, right, its value is at 0, and that is why here inside this orbit, inside here, when I'm multiplying 100 with water value inside the animation value is at the beginning it is 0. That's why here the radius is effectively 0, so you are not seeing anything here. So if you want to see that, right, you need to make sure the UI gets rebuilt. So for that I can use add listener method of the animation controller, and inside the add listener I can just call set state. That's all. If I do this, I have to hot restart. Now the reason why nothing is happening is because I have not actually started my animation. For that, what I need to do is call animation controller.forward, and this way the animation starts. And if I hot restart again, you can see that we have a sun here. If I zoom in, right, there is a small sun here. If the widget rebuilds again, in the value of animation changes. But to make it more smooth, right, I can do one thing. I can call it, right, animation. After calling animation controller.forward, I can say animation controller.repeat. And the reason why we cannot see the animation happening is because in our custom painter class, our orbit painter, there is another function we have overridden called should repaint. And according to the word meaning, if you want to repaint your canvas, if you want to change how your canvas looks again, right, you have to return this thing as true. So if I pass this to be true, and if I hot reset again, you can see, and now the canvas is getting repainted, and accordingly we can also see how the radius of the sun is changing over time, because I am multiplying 100 with water value, animation value that I'm getting here. So this is sweet because now we know the animation is working perfectly. What we want to do next is, we don't want the sun to be growing bigger, right? We want the earth to move around this orbit, and we want to use this animation value just for that. So what I'm going to do, I'm going to remove this code of multiplying animation controller from 100. I'm going to hot restart, hot load again. So the next thing we want to do is how to move the earth around the sun. So to do that, there are a couple of ways to do this. We can either rotate the canvas altogether, and since our sun is a circle and it is always at the center of the canvas, it will appear that the earth is moving around. Or we can do another thing, we can use the maths, we can use some simple trigonometry to calculate where the earth should be, and using that we can change the offset of the position of this circle, which is our earth. And the first thing we have to do is import this math package. The reason why we have to import the math class is to use its sine and cosine functionalities. I have written here that the height I want it to be at the center of our canvas at the Y position, and plus 200 distance away from the center. So that's why the earth is here, 200 distance away from the center of the center circle. And if I multiply this 200 with sine value of animation, and if I hot reload again, you can see now that according to the animation, and our earth is moving at a distance here, right? And since we are only multiplying it for the Y value of the offset, it is moving at the Y distance. And now what we want to do is multiply the same for the X distance of the offset. First of all, I need to add this 200 also, and then I'm going to multiply it with the cos, and let's just pass in the animation dot value. And if I hot reload again, now you can see the earth is moving at the orbit, and this is what we want to achieve. And the first parameter inside the draw circle is the offset. It is where we want the center of our circle to be, and since we are multiplying the X value of the offset and the Y value of the offset with the animation, and since the animation is changing between 0 and 1 during the 5 seconds of duration we have given, and the X position is also changing for every rebuild of the widget, and also the Y position is also changing for every rebuild of the widget. So the next part in our animation is to make sure that the Earth can complete one whole revolution around the Sun. The first thing that might be coming into your mind is then we can increase in this duration, but it doesn't work that. If I do the same thing here again, right? The way animation controller works is that by default the upper and lower bound is 1 and 0. So the animation value will move between 0 and 1, and the duration we pass here is how long it should take to move between the lower bound and the upper bound. So if you want the animation to be slower or faster, you can change the duration, but the bound is still the same. So how to change the bound is the question we have to ask. So to that, inside our animation controller constructor, right, we have by default lower bound as 0, like I said, and upper bound as 1. So if you want to change the distance that the Earth covers, basically if you want to change the animation value upper bound and lower bound, we have to change these default values. So what I'm going to do here is, I want the lower bound to be 0, right, but I want the upper bound to be something different. So for example, I want the upper bound to be like 4 instead of 1. And if I hold restart again, you can see now the Earth is moving a little bit further away. Yes, it is moving way further away than 1, and it is going, and yeah, now it jumped from this position, right? And now we cannot actually find the number like this, how much we want, right? And it depends upon many other reasons as well. So the best thing we want to do is, we can pass some other values here, something called pi. So if I pass pi, which is a value 3.14, right, and if I click on this, hold reset again, now it will not come up to this point because that was 4. It will end somewhere around here. Yeah, you can see that. So if I multiply our pi by 2, right, so it will be 2 times pi, and if I hold reset again, now you can see that the animation is going. So far so good, and it is making a one complete revolution, and it is repeating. To our eyes, it is a continuous motion. So this is how you can create a solar system animation where the Earth revolves around the Sun in a continuous manner. And all the source code for this video will be available on the GitHub by the time you will be seeing this video, and every video that I make going from this moment onwards as well, all the source code will be available. And if you like seeing more videos like this, right, then do support me and do let me know by liking the video and also by subscribing to my channel as well.